Okay, by my clock, it's time for us to begin. Tim's not shown up, so I will go ahead and get us started, and hopefully we'll be able to transition to him. Okay, so welcome to the last slot of IETF 110. This is the LAMPS working group. This is the note well. By this slot, you've probably seen this a lot this week. Please make sure you understand it before you contribute. This is the first page of the agenda. Basically a couple documents that are nearly finished, then the documents we're actively working, and then some things we're thinking about bringing on board, some of which require recharter and some of which do not. We'll see how much of these we can get to. Is there any agenda bashing?
Just wanted to mention, this is DKG. Just wanted to mention that the two items on there that have my handle attached to them may actually depend on a third item. So I will mention that during the talk, but just want to give a heads up that this sample certs seems kind of dependent on these.
I see. Okay. All right, so I'm not hearing any agenda bashes. We do need a note taker. Can somebody take notes in CodeMD, please?
I can do it.
Thank you very much. And okay. So
I just got back to the keyboard. I noticed you're flying solo. Would it be easier if I projected the slides so you can better do the facilitation?
that would help a lot.
Yeah, sure.
Since
yeah, I figured. So give me a second to get it all jiggled, and I'll start presenting.
Thank you. Let me stop. Yeah, I thought Tim was going to run the slides.
Have it ready. Everyone just be patient. Can you give me permission, Russ, to share the screen?
Oh, I'm sorry. I thought AD had that permission.
So did I.
Okay. It clearly knows you're the AD. Ah, here comes Tim. Well, let's do the first presentation, which is mine. And then there we go. Thank you. All right. So I'm going to talk about the two documents that are about GMAC and CRMF algorithm update. Next slide. The GMAC document provides OIDs and parameters for using AES GMAC. IESG evaluation raised a few comments, and they were make RFC 5912 a normative reference since the ASN1 doesn't import from there, and expand the security considerations. Did both of those, and with those changes, it is now approved, and I saw that it is shifting to the ISG, from the ISG to the RFC editor, I think this week. Next slide. The CRMF update now allows PBMac1 from RFC 8018 as an alternative for the password-based MAC, which is defined in the document. For the password-based MAC, we transitioned the one-way function from SHA-1 to SHA-256. That is the thing that started the whole update. And then we modernized guidance on what the iteration count should be. The MAC algorithms, we said that HMAC SHA-256 is the must, and AES-GMAC with a 128-bit key is the should for use with password-based MAC. So those are parallel to the, the password-based MAC is the must implement, and the PB MAC that I talk about in the first bullet is just listed as a may. And IETF last call is underway right now. So this one is with the ISG and should be wrapping up shortly. Any questions about any of those? Okay. Tim, are you ready to take over the screen, or should Roman continue?
Hey, can you hear me?
Yes.
I believe I have gotten all my Chrome permissions issues fixed. I believe I'm ready, yes.
Okay. Roman, would you stop sharing?
All right.
All right. And the next slide is header protection. That's the deck we want you to put up, and I'll pass the microphone to DKG.
Hello, folks. So as the slides are coming up, this is about protecting the headers of emails with cryptographic protection. Just for context, we care about different kinds of cryptographic protection. That includes signed-only messages, as well as signed and encrypted messages. And I will be talking about the progress that's been made on the draft, what our next steps are, and some test vectors, which offer you some opportunity as a working group participant or as an implementer to take a look at these things and see what they do to your mail user agent, whether that's the mail user agent that you use in daily life or the mail user agent that you are working on. We'll wait for the slides to come up.
Tim, we're still not seeing slides. Are you sharing your screen?
I'm in the middle of closing down everything else that's in Chrome because it's the only PDF viewer I have set up right now. So
we don't want to read your email, Tim.
Oh no, he just went offline.
Should I try to share?
I'm sending a request so you can let me share.
Yeah.
Roman, saving the day again.
Thank you so much, Roman.
No worries.
I don't know how many days you can save it in one day, but it's appreciated.
Let me just make that bigger.
Compliance with PDFA standard. I didn't know I'd done that.
Let's just keep going.
Yep, that works. Okay, so draft 03 has come out, draft IETF LAMPS header protection 03. The big changes from 02 to 03 are that we are now explicitly describing the two different schemes of header protection that are seen in the wild. One of them is a wrapped message, which is what is defined in SMIME 3.1 going forward, but hasn't actually been widely implemented from what I've been able to see. The other one is called Injected Headers, which was originally documented here in a draft autocrypt that I was responsible for. It's also been known in the past as memory hole. It's been more widely used in the PGP world, but the mechanism is still available for folks who want to use it for SMIME. We're focusing in this draft on the SMIME part. The draft 03 talks, the main change there is that there are now some explicit algorithms for how to encode a message when you're composing it using these types of protections. They use some examples they use some of the framing from the draft DKG E2E mail guidance, which I'll talk about probably later in the day. But it's a pretty straightforward set of encoding proposals. It is less straightforward than just the standard encryption because the standard encryption only covered the body of the message. And 03 also introduces this header confidentiality policy object. I talked about this at the IETF109, the header confidentiality policy object, and I'll give a brief recap on it here again. But those are the two main changes in -03, right? The description of the two schemes, I guess three main changes, talking about how to compose them, and as part of composing them, this HCP. Next slide, please. Administratively, I'm now the lead editor. Bernie had been doing that. Thanks a lot to Bernie for pushing on this all along. Bernie and Ecdsa are still co-editors, so you can lean on them as well as me. But if you have specific problems and I'm not responsive, I think I'm the main one to blame. I moved the editing workflow to GitLab so that there is an issue tracker, and the document is represented in Markdown. People should be able to send merge requests and issues there. But if you do that, please also send them to the list. The list is the canonical place. I still find issue tracking extremely useful for taking care of problems. So if you can open issues as well as sending to the list, that would be great. Next slide, please. And if anyone has any concerns here, along the way, please speak up. Here is a description. You may recognize this slide from IETF 109 of the two different header protection schemes that are described in the document. The wrapped message format takes both schemes look just at what is inside the cryptographic envelope. Cryptographic envelope is the layers of cryptographic protection, the MIME layers, like multi-part signed or the various S-MIME layerings. So we just look at what is inside those, immediately inside those. A wrapped message is a message RFCA22 object as the first level message, the first level object inside the payload. It has a special flag that says forwarded equals no. And the headers that are protected show up in what is labeled as part B in this picture here on the top level part within that RFCA22 header. So that's where the protected headers land. Again, this works for encryption as well as signing. For injected headers, there is no message RFCA22 interstitial part. It is just an attribute, or a parameter rather, for the content type, and the headers are placed directly on the content, on the MIME headers of the top level part of the cryptographic payload. So that's part D over on the right-hand column. Now, that's again for signed and encrypted. For encrypted messages, there's an additional issue here, which is that a legacy client that receives an injected headers style message, but has some confidentiality of headers on the outside. That is, some of the headers have been stripped off the outside so they're not exposed to the transport. The legacy client might not be able to actually view any of the headers because the stuff that is in the header section for the top level MIME part is not generally visible. So there is this additional wrinkle to the injected headers, which is that the composing client can, if it wants to, add this additional legacy display part. And that is just a text plain part that is a purely decorative part that implementations that understand this structure will ignore, and legacy clients will display to the user. And so you can see there, the way that that's done is that it makes the top level part of the cryptographic payload multi-part mixed, again with the same content type parameter, protected headers equals v1, and then it has two parts, and those two parts are a text plain part, that's the legacy display part, and the second part is what would have actually been the original message. So you can see in this picture that BCD is analogous to DEF, which is analogous to IJK. So that's the actual message that's being sent. And these are just different ways that the message might be bundled up as a cryptographic payload for the client to receive. Next slide, please. Okay, so in order to do the encrypted part and actually produce some effect, right, the encryption provides confidentiality. In order to get the confidentiality properties that you want, you have to also remove the headers from the outside. For a signed only message, you just copy the headers. They're in the outside. They're also within the cryptographic envelope. But for encryption, you want to do something to the outside headers so that the ones that are inside the cryptographic envelope are actually confidential. You don't want the extra copy on the outside. That's tricky to do for transport, and to decide which particular headers should be stripped or munged or how they should be munged is a complicated question that this draft does not hope to resolve. Instead, what this draft does is it presents this abstraction of a header confidentiality policy which implementers can use to talk to each other about the way that they are protecting the outside headers. This is again in encrypted only, in messages that have encryption. This is the only place where we care about the HCP. This is modeled as a function which takes two parameters: the original header name, the name of the header field, and the original value of the header field, and it produces a value, an output value that belongs on the outside. If that output value that's produced is null, then the header itself will be omitted from the resulting message. So this is just a way to think about how do you protect the outside, and we'll talk about, I think next slide, if we go to the next slide, we can talk about two different header confidentiality policies that are possible. This document currently contemplates two. I think we should only recommend one just because it's too messy to describe multiple ones, but I imagine this being something that implementers will iterate on and communicate about in the future. The two that are described in the document are what we call header confidentiality policy minimal and the HCP strong. The minimal approach basically says, don't protect anything but the subject in terms of confidentiality, and you protect the subject by replacing it with square bracket, ... square bracket. The strong variant says, leave from to CC and date alone, protect subject in the same way that HCP minimal protects it, scramble the message ID by replacing it with a new message ID, and remove everything else. So those are two different variants. They have some different trade-offs. Hopefully we will get some test vectors that illuminate the difference between those two, but we don't have them yet. People can come up with other HCP proposals and talk about them, and that would be great. I look forward to hearing those discussions. This is just an attempt to normalize the idea that this is how we talk about it. So yeah, next slide, please. We do have test vectors now. These test vectors are published. If you point your browser at the first link there, that's header-protection.cmrg.net, you'll see a web page that describes them. It's a very crude web page. Please take no offense at my web design skills. There is basically no web design going on there, but it hopefully gives you the data that you need to see them. They are also published via IMAP. So if you have an IMAP-capable client, you can point your client at this particular IMAP mailbox. Any password will work. It is, if you want to change things in the mailbox, maybe the changes will work, but they certainly won't last past your IMAP session. It's sort of a persistently, it's persistently ephemeral, if that's the right term. It'll always show up the same when you connect back to it. I've used this particular IMAP mailbox to look at the messages with Geary, which is a legacy client that does no crypto at all, and to look at messages with Thunderbird, which is also a legacy client, but it is a legacy client that does crypto. I would love to see some reports from people about what it looks like to point their mail user agents at these messages. The messages that are in the mailbox include simple message that has no cryptography exposed at all. It's a handful of messages that do SMIME on them, but no header protection, and then the different header protection schemes that are there, combined for the encrypted and signed messages with the two different proposed header confidentiality policies. I wanted to the rest of this presentation is just a chance to explain the way that I've done some evaluation of these messages. using these legacy clients. And I'm going to, if you go to the next slide, you'll see, and again, this is, this is a call for what we want for the test vectors. Maybe we'll skip over this one for now. We can come back to it. But just so you know, I am looking for people to test. Next slide, please. At IETF109, wow, I'm jumping the gun here. Okay, so we will talk about test vectors in a second. I forgot the way that I had organized these slides. Coming up for 04, I think we want to add guidance for receiving side in terms of how to deal with these messages, and guidance for the replying side, which I think is slightly different from just rendering. And you'll see in the test vectors explanations that I get to at the end here about the difference between rendering and replying. I do think that we are going to want to recommend a specific scheme for generation, but I suspect that clients will need to be able to handle both schemes on consumption. So it's just something to think about. I also think that we should select a recommended header confidentiality policy. I don't know that all of that will happen in 04. 04 might end up just being the test vectors themselves, which I plan to publish as part of the RFC, unless I hear objections from the working group. I will publish them as embedded MIME objects, basically. Yeah, next slide, please. So you might remember from IETF 109, I presented this matrix to say this is how I would think we should be evaluating the scheme for message composition. Obviously for clients that have fully implemented consuming a message with header protection, the results for any type of message composition will be good, because that's the definition of having implemented it. And for clients that have no cryptography available to them, the results will be unreadable, with the exception of multi-part signed, which is potentially readable by clients with no crypto. So the real question that we have are the unfilled boxes here. How does a legacy client respond to a message that has header protection in these different ways? How do they render it, and how do they reply to it? So those unfilled boxes really are the boxes that we are looking at in an evaluation. And like I said, I looked at Geary and I looked at Thunderbird. Geary fits in sort of the yellow column here, and Thunderbird's in the blue column. So if you go next, I'll show you some evaluations that I did. And I invite other people to replicate these experiments. So this is Geary's configuration. The slides are a little bit small. If it's possible to full screen them, it'll be easier to see what's going on. Sorry, Roman. Thank you. Still a little bit on the small side, which is my bad, but hopefully we can make some sense of it. So this is Geary. It's a legacy client that does no crypto at all, and I pointed it at this IMEP mailbox. Next slide. I started by looking at how it rendered the. You may want to maximize this in your Meet Echo view if you want to take a look at this, or you can pull up the slides distinctly if you want. I took a wrapped message and an injected headers message, and I put them, and I loaded each of them in Geary. Now I didn't bother with the encrypted ones or the one part. This is all just the SMIME multi-part signed only messages. And you can see on the left how the wrapped message looks. It has a weird double header view. And on the right, you see the injected headers. It looks like again, it's a little bit weird because it has this SMIME attachment, but that's standard for any SMIME multi-part signed message. So in this case, I looked at it with Geary, and it looks to me like the left-hand side is a little bit more confusing because the users don't know how to interpret this duplicate header. But I think the one on the right is still confusing, but maybe marginally less confusing because the only thing they're dealing with is this mysterious attachment. I'm sure people in this working group have had people reply and say, I can't read your attachment before. That's just sort of par for the course for multi-part signed. Next slide, you can see in the upper right in these slides which box of the evaluation grid we're looking at. So here's how Geary replies to a multi-part signed message. For the wrapped message, it doesn't actually manage to quote any of the text, which may be surprising to people. I don't know how you feel about quoted and attributed text, but the expectation of most users is that it will be there. For the injected headers message structure, we can see that the message text is there. So I'm not a big fan of top posting, but I do understand what this is. This is an expectation for most people. Again, injected headers seems to meet user expectation for legacy clients better. Next slide. Here is a configuration for Thunderbird pointing at the same data. So I went ahead and tried to evaluate these 6 different boxes. So I'm going to blow through these pretty quickly because I don't want to spend a ton of time on it. Next slide. But just so you get a feel for it, for how things look. This is multi-part signed. Again, we have this weird duplicate header thing on the left with Thunderbird. Note also that the SMIME signature is broken. Now that's pretty odd. I generated the code. You can find the code generation in the GitLab repo. All right, so I've generated these messages just directly with Python and a couple of external tools for doing the signatures. Maybe I screwed something up, but if I screwed something up, I don't know what it is. So maybe somebody who's smarter at understanding SMIME can figure out why that signature breakage is showing up there. Again, injected headers looks a little bit cleaner, and it does have a valid signature. Next slide. Here we look at replies. Again, Thunderbird exhibits the same quirky reply behavior where the quoted and attributed text is missing with the injected headers from multi-part signed. So again, I'm leaning in the direction of injected headers here. Next slide, please. This is SMIME single part signed only message using the SMIME signed data structure. Here you see that the SMIME signature is not broken, but you still see the weird double header on the wrapped message variant. The injected headers, you see the successful SMIME signature, but you don't see the duplicate headers. So this looks a little bit better again in the injected headers case. Next slide. Here we'll see a reply. We see reply again having the same quirks, where the quoted and attributed text is missing in wrapped messages and not missing in injected headers. Next slide. All right, here is the encrypted and signed message. And sorry, these are smaller. What you can see here is that the wrapped message is signed and verified correctly, but has this weird duplicate subject header block internally. The injected headers, if you don't use the legacy display part, looks pretty normal. It's signed and decrypted successfully, but the subject line of the message is completely missing. So in this case, if you just use injected headers without the legacy display, the legacy client is going to look at this and be like, okay, we got the message, but we don't know what the actual original subject line is. At least in the wrapped message, you can see the subject line show up in this duplicate header block. In injected headers with legacy display, you can see both. You can see the subject line and then a sort of weird bar, and then below that subject line, you see the text of the message. So again, of these three, it's kind of problematic for the injected headers without legacy display. The legacy client can't find the subject line at all. It doesn't render it. But both the left and the right do render the subject line. And on the left, we see it, again, there's this weird full header block, not just the subject. Next slide. This is looking at replies for the same set of messages.
So Bernie has his hand up.
Okay, yeah.
Well, we can wait to the end.
This is the end. So if you, just give me 15 seconds here. For replies, we see the same quirk on the replying to the wrapped message. We see, again, the reply without the legacy display for injected headers in the middle and with legacy display on the right. There is a weird artifact there in Thunderbird where it has a box between the subject and the response. But you can see that both the internal subject and the message body show up in the quoted and attributed text. So that's my experience with trying to diagnose how these things look. Bernie, you want to step up?
If you can go back to slide 15. Roman, can you go back to slide 15? Thanks.
He's going.
Just
Great.
at a race condition. Yeah. Here I have a question if you see on the wrap message approach, you can click there on the attachment part and then potentially reply to that attachment and things look good. How is that the case, and how does it look with the right parts? Do you have a chance to actually see the message by clicking, or don't you have a chance at all?
So I think you're describing a user workflow that involves interacting with the attachment somehow. Is that right?
Kind of.
The injected headers
to...
doesn't show any sort of attachment whatsoever. So no, there is no additional like a message-specific workflow other than just viewing the message with the injected headers model.
Yeah, but you don't see the content of the message in this part. You only see like a hint that you don't really see the message. Is that correct? Or
I
wait
think
a
you
second.
do. You're seeing.
Yeah. Okay. Sorry, I thought it was kind of a standard text here. So that is what the text what you put in, what you see.
Yeah,
here.
that is the text of the message. These are not very interesting messages. They are test vector messages. Yeah.
Yeah. Okay, that was a confusion. Yeah. So the difference is only like that you see some double header on the left side, and on the right side you see only this.
Well, there's actually two
user would
differences.
expect.
I think there's two differences. On the left, there are three. On the left side, you see this duplicate header. You see an attachment, which is listed as a .eml. The .eml is an artifact of the way that I generated it. Probably you could say anything in there. But you also see that, at least in this particular one, in multi-part signed, the SMIME signature is not being validated. So either I've generated it wrong, in which case I welcome help in that, or this legacy client has trouble validating a signature over a wrapped message.
Okay, so but if you would click on the attachment and then reply, the reply would come good. It's just like a nuisance for the user.
You know, it didn't even occur to me that I could do that. I didn't even try it.
Okay, so you assume that the dummy user also doesn't do that.
I confess I did. I thought the user was probably as ignorant of this process as I was, and probably more ignorant of it. But it did not even occur to me to click on that .email. I could try that again, or maybe you want to try that with your with your own.
It's fine for the moment.
And report on it.
I was mainly misinterpreting what you showed here in the content of the message, and it's now got clear. I guess the same is in 17 and 19. It's basically the same happening. Or if you go to slide
although
17.
in 17 and 19, there's no the signature doesn't fail. So the signature is correct. The signature works when I'm using SMIME signed data.
Yeah. Okay. Well, got clear. Thanks.
So Roman, if you could just actually take it back to the slide before.
Before you do that, can you go back? I think you're actually seeing the contents of the attachment on the left.
Yes, I agree with you.
Slide 15.
You are seeing the contents of the attachment there.
Because the titles are the same, right?
Yep, that's right. That's what's happening there.
Okay, so that's...
So I'm not sure. I mean, clicking with it might put you in a slightly different interface that would make the reply behave differently. Like the reply might actually include the attributed text if you replied from the view where you click on the EML. But it didn't even occur to me to click on that. So.
But the broken signature is really important.
Yeah, that's pretty weird. And I welcome, I hope people will take a look at these objects and tell me, and the generation code is all committed. It's Python. It is actually reproducible for me. I can rerun it twice and get the same objects out.
Alexi?
I generated similar wrap messages with my own email clients, and it verifies in Thunderbird.
Great. Then maybe you can send me an example, or you can take a look at my generation code and figure out what I'm doing wrong. I would appreciate that, because I'm using basically very, very parallel code paths to generate all of these messages. And so it surprised me that the wrap message was somehow not verified.
Well,
so Alexi, you don't get the broken signature?
Your examples in my client and see if they verify, so which will give some indication whether it's right or wrong.
Yeah, that would be great.
So what I think I understand from what Alexei just said is he'll compare his client to this Thunderbird to find out if it's a bug in Thunderbird.
I think that's right. Yeah. So Roman, if you could go back, I think it's slide 8 or 9. Yep, that one right there. Help with the test vectors. So I would love folks to look at these test vectors with different mail user agents. If you can take a look and you can send a report to the mailing list, or you can open an issue on GitLab, I will summarize the issues back to the mailing list if people do that. If you want to take screenshots, it's a little tedious to take screenshots of 12 messages, or about 12 messages. But if you do that and you want to submit a merge request, you can see some screenshots already stored in the repo there. If you can help me debug the multi-part signed wrapped message, that would be great. We have an outstanding idea to try to be able to generate and send test vectors through live mail servers. Doing that without landing on spam lists is a little troublesome. I'm not sure. But we were thinking about trying to set that up. If folks are interested, please reach out on the list and let me know. I think it would be useful to see how these messages get mangled when they go through mail transport agents as well. And if you have ideas for other things that need to be evaluated, let me know. I noticed when I was testing it, one major thing that we don't have is any messages that differentiate really significantly between the HCP variants, strong and minimal. So I'm in the process right now of adding an additional test vector that should show up as a threaded message, but the threading might break on legacy clients for strong, but not break on legacy clients for minimal, just so we have a way to look at the differences there. But if there are other things that need to be evaluated, I'd be happy to hear about them on the list, or again, as issues in GitLab, which I will relay to the list if they show up only there. Yeah, so the messages are all just using text plain as the body of the message, because I didn't want to introduce too many additional wrinkles and variations. There's no attachments. It's not multi-part alternative. If I can do all kinds of additional test messages, but I worry about making 25 messages and asking people to tediously inspect all of them with their mail user agent. I'm trying to keep it a little bit tight. Bernie, you're in the queue.
Yeah, I comment what I commented to you directly already, that I believe to really get the whole scope of this research, we need to have something more than just text to really see whether it works. And I should suggest to have like one more, it's not a dimension, but like blow up with this dimension that we have a multi-part alternative and an attachment like in the same message as a second one in that dimension. Because I believe there are differences you can see if it's only like the text or if you have some more. I hope I'm wrong, but I still would like to exclude that. We don't need to do that for all kind of other dimensions, but at least we should exclude that we're introducing new issues with other MIME structures.
Yeah, so I can see at least 2 other MIME structures that seem common. Maybe we could say it's 3. And I'm reluctant to multiply the number of test vectors by 4, but the 3 structures that I can imagine are multiple alternative with text plain and text HTML, text plain with a single attachment, that is, I don't know, a PNG, and multi-part alternative with an attachment. Those are 3 significantly different MIME structures that I could put in place. Do folks have a preference for what kinds of things should be there? Do we want to, I mean, again, I think if we ask people to look at 45 messages instead of 11, it's going to be a tough lift. But at the same time, I agree, those are common patterns. I don't know how people feel about test vectors like this. The draft also will bloat in size as we increase the number of variants. I'd love to hear thoughts from folks in the working group about what specifically we should do. Alexei says multi-part mixed is enough. Alexei, I believe what that means is like a text plain. Maybe we should try multi-part mix with just a text HTML and a PNG. With no text plain? Alexei says sure. Bernie, I think you're at the top of the queue. You should just pop up.
Well, just repeat what I said before. My suggestion would be have a text and then something else with a complicated MIME structure. It should be multi-part alternative plus an attachment. Basically
Okay,
saying the
so-
same as I said before. That would be my preference, but there could be more. But I see also like we have kind of a limitation in how many test cases the people are willing to handle. We could actually produce some more complicated test cases in another mailbox for those who want to do more. That's also an option to not to scare away the people.
Can I ask who in the working group here would be up for, I'm not sure exactly how to do this with maybe show of hands or something, but like who here would be willing to test looking at a dozen messages with a mail user agent that hasn't been looked at yet? Is there anybody who'd be willing to do that? Who's here? It could be an existing client that has full crypto capability. It could be a legacy client, in which case you'd only have to look for a few. Yeah, volunteer
Okay,
from one
I've
of the
started a
co-authors.
poll. It says, are you willing to look at a dozen test messages? At least we'll get a feel for how many people are willing to contribute to this effort. So if you would raise your hand if you're willing to do that, and either do nothing or do not raise hand if you're not.
Dan, while we're doing that, can you refresh people's memories on which ones have already been looked at and which ones you're particularly interested in?
I think you're asking which mail user agents I've looked at.
Yes.
Right. So I have examined it with Geary 3.38.1 and Thunderbird 78.8. And I'm in the process of taking a look at Evolution and Not Much. As a free software developer, these are the kinds of tools that are most readily available for me, but I recognize that there's a bunch of proprietary tools out there too.
So in your previous set of vectors, I did Mac's Mail App and I did MailMate and sent you the screenshots. And 6 people are willing to help you by looking at a dozen messages. That's
great. That would be, Tim, I see you volunteering to do Outlook. That would be awesome. I would appreciate it. Wow, lots of volunteers for Outlook. Yeah, so to do this, if you're using a crypto-capable client, which I believe the full-blown Outlook is, then you're going to want to load the sample CA. There's instructions on how to do that directly on the HTTPS link from the slides, which I'll put in the chat as well. But again, if you've got a client that's not crypto-capable at all, or you just don't want to bother with the crypto stuff, you feel free to just do 3 messages with your client and send a report. That would be great, because it's still useful just to look at that multi-part sign message and see what happens. Yes, there was a separate repo from the earlier AutoCrypt draft that didn't include the wrapped message views. So our goal here is we've got these 2 different variants of how people are doing this stuff, and we want to be able to see both of them. So I appreciate the folks who submitted to the previous repo, but this one is a different one. So I just put the URL for the follow-up there. But yeah, if you look in the slides, you can, reports to the list are great. You can report to me privately if you like, or you can do a merge request on GitLab. So Yoav, I don't know if that's a volunteering from you to check with some popular Android plans, but if it is, I owe you a beverage of your choice the next time we get to see each other together in person. Great, thank you. Much appreciated. Bernie?
We didn't really discuss now the proposal that we do something more than just text attachments. So how would we go on with this alternative thing? You mentioned that we will put only this like initial 11 message there, which I believe does not include multi-part alternative attachment stuff.
Yeah, so the messages are all ordered in terms of time. Each message has a distinct minute-by-minute timestamp. And probably when you view them in your mail user agent, you'll see them in that order. Get through as many of them as you can. We are probably going to add some additional vectors that will include more complex structures, and those will be in later minutes. So you can get to those if you can get to them. That would be appreciated. And if you can only report on the simpler ones, you can also just report on the simpler ones. But I think, does that make sense, Bernie, as a way to handle that?
Well, as long as we are not only evaluating text plain messages,
Yeah.
I'm fine. I think we need more because the structure itself kind of indicates that there may be differences.
Yep, I think that
Like
makes sense.
what I said before, basically. So
Yep.
if we don't just exclude them and make our decisions based on text plain, that's a bad idea.
I hear that. Are folks okay with all of these test vectors going into the draft? I feel like the draft is going to be very large because of the test vectors. And while I don't particularly mind that, right? They're going to be in an appendix. I do think it's useful to have a stable reference for them, but I don't know if people feel like we're somehow doing wrong by making a draft that's super long with all of these example pieces. Any thoughts on that, either from the working group or from the chairs? Thank you, Roman. I don't see an issue with a large appendix. Jonathan, interesting.
Yeah. I was just going to say, I feel the same way. I think lots of text vectors is generally better. And if we have to put them in another place just to avoid blowing up the universe, that's fine. But yeah.
So I'm not sure what universe gets blown up by including them. I mean, the draft still is much smaller than, a 10-second YouTube clip.
Yeah, exactly. I feel the same way. Text vectors are generally, pretty short, and bandwidth is cheap these days.
Yeah. Jonathan, you mentioned that Ecdsa, in the chat, you mentioned that Ecdsa refers to an external repo. My worry is just that maintaining an external repo is a job, and it isn't necessarily always done super well, and that external repo might change over time, and then it's not clear what people are doing, and having a stable reference is a really useful thing for the stuff. So while I do intend to maintain the repo separately, and I do intend to maintain this IMAP mailbox indefinitely for people to test their mail user agents on it, I might well fall down at that. Whereas I'm pretty sure the IETF will not fall down at continuing to publish the draft. And if it does, we have other problems. So that's why I sort of lean towards having them in the draft.
So Daniel, I was actually going to suggest both. So the enduring thing will be what you have in the appendix, but practically if I wanted to use the test vector, I'd prefer to just download it somewhere and not have to cut and paste it out of the document. And so at some point, maybe your repo goes away and I still have what you need in the RFC itself.
Yeah, I agree with that. It's certainly hard to extract stuff from the RFC. The Draft 03 uses XML to RFC in the XML v3 format, and each object is labeled as a source code object with the appropriate type designation and a file name. So part of the answer to that may be to ask the publication queue to make it easier to extract those things automatically from a document that has them embedded appropriately in the source XML. But I'm also currently publishing, if you go to that URL that I put in place, it's being published as an mbox file, as a pkzip compressed maildir, and also available for download as individual .eml files, plus, of course, the IMAP view.
So DKG, you might want to take a look at the S5 examples document that Paul Hoffman did. He put in an appendix a Perl script that if you run over the RFC, pulls all the objects out.
I saw
It's
that
self-extracting.
and I ran screaming. I don't know. I kind of feel like the messages that we're talking about are plain text, and they should be publishable as plain text. And it was hard for me to imagine.
It worked, for getting a whole bunch of developers to have the same objects.
Right.
Yeah. I don't know if it would work well here, but the other thing that's extremely useful is if you are using some source code to generate your test vectors, publishing that is extremely useful because it allows people to generate more test vectors if those are useful to them, or just like tweak them if they're trying to track down a bug and things like that.
Yes. So the test vectors that we are including here are generated from source. They're in a Python script that's in the repository that contains the markdown source for the draft itself. I have not tried to put the Python script into the draft. I don't know whether you're encouraging me to do that or not. I could consider it. The Python script, actually, I've tried to make a point of generating repeatable test vectors, which is a little odd because the signatures are not necessarily deterministic, and encryption is definitely not deterministic. I actually haven't succeeded with the encryption. But yeah, my intent is certainly that people can look at that script, see how it's being generated, and tell me if I'm doing something wrong as well. So I welcome review on that. Review and patches. If you say, hey, this should be generated this other way, and you want to send me a patch, and it should be pretty straightforward Python. It works for me in a modern Debian environment. If you want to experiment with that and tell me how to improve it for your use case, that would be great too. Yeah, so I think that covers this. I want to note here that these test vectors all depend on the cryptographic objects that are published in draft DKG LAMPS samples. And that is basically a chunk of RSA. There's an RSA certificate authority, a pair of RSA certificates for Alice, and a pair of RSA certificates for Bob. In order to make these test vectors work, you need to have access to those things. It also has all the secret key material available. Thanks to Deb Cooley for pointing out that the earlier versions of draft DKG LAMP samples they reused the same RSA keys for both signing and encryption, which is generally considered a bad idea. The new draft fixes that. I kind of think in order to get that draft out there, it would be great to consider adoption of that draft by the working group as well. I don't really know the process for doing it, but it certainly seems like a useful thing to just have a set of sample objects. I was looking today at with Bob Moskowitz at putting curve 25519 and ED 25519 and maybe curve 448 into the draft as well. I haven't done that yet, and I'm sorry I don't have slides for that presentation, but if having sample vectors, they're represented in the draft as PEM format objects, again with the same XML v3 source code annotations, so they should be extractable if there's tooling to extract the source code. I'd be happy to see the working group take that over and have me lose change control over the document. I don't necessarily want to be responsible for it. I looked for it and couldn't find it for modern crypto, so that's why it's there. Russ, you're as chair, or Tim, is that something that y'all want to consider? I think it's actually already in Charter in terms of providing useful tooling and guidance for implementers.
I do agree that it's in Charter. I think we just need to hear whether people want to work on it, want to review it.
Does that mean a call for hands, or I don't really know what the right process is here. Or Roman, do you have any concerns?
Well, I'd like to hear somebody speak up and say they would like to see that work go forward or not.
Deb's asking to repeat the question. So we're talking about draft DKG LAMPS samples, and whether this should be adopted by the working group. I believe it's already in Charter. What it contains is an RSA certificate authority, secret key and public key, a sample certificate authority. And for two different users, Alice and Bob, it contains a RSA certificate for signing for each of them and an RSA certificate for message encryption for each of them that are intended to be used for S/MIME.
Okay, I see several people speaking for. I don't see anyone speaking against. So I'll do an official call on the list, and
Okay.
we'll start that next week. It's kind of, everybody's kind of burnt out, I think, at this point of the
I
game.
get it. When you do that call, I will need some guidance on, do I just like change the draft name and upload, or what the process is there?
Sure,
and you
I'll be
can
glad
include
to,
that in the message.
I'll be glad to tell you on the successful call for adoption message.
Right.
Right.
I also welcome people who want to step up as editors for that draft, whether it's as if they want to take over lead editor role, or if they want to just be a co-editor. You know, it doesn't need to be me that's the editor for it if other folks want to participate. So. Yep. I think this presentation is reached its end. Thank you.
Yep. I think we need to move to Hendrik and his 3 documents in one presentation, all related to CMP.
Yeah, hello everybody. So it's Friday afternoon, at least here in Munich, and I thank you all for still joining. There is quite some progress on the 3 documents, so we managed to get support from Entrust on the CMP algorithms document, and also my colleague David, who is also active in OpenSSL, stepped in to support the Cmp Updates document. So I would say since last summer there is quite good progress, also due to the guidance from the 2 IETF meetings, and I will just quickly go through the status and the open issues that I see as of today. Next slide, please. So since last IETF, a lot of the topics were tackled. So in all of the section, there was some throwing out older stuff and updating or adding other things that we discussed either in the meeting or on the mailing list. So I think I do not need to go through all of the points. You will find that also in the appendix of the draft to track where these changes originate from. Next slide, please. So there is also this section 7 that was formerly Appendix A. We pulled this forward in the document to give the section 7.2, which replaces the mandatory to implement algorithm profile for RFC 4210, a more prominent position. And yeah, there is a proposal for some algorithms to be implemented with a lightweight CMP profile. So I'm welcome to get feedback whether this makes sense. We discussed internally quite a while and thought as the lightweight CMP profile is more a message profile than an algorithms profile, and we not we know that there are quite various algorithms in the different use cases or environments used. So therefore, maybe a mandatory to implement profile is not helping, and maybe it can be left open for those industries making use of the profile. Okay, next slide, please.
Point out that that is the same conclusion we came to with 5280, that a mandatory to implement signature algorithm for all certificates was clearly not viable, and I think you have the same kind of argument here.
Yeah, actually, and a lot of the algorithms that need to be implemented or used heavily depend on the certificates used for signing messages and the certificates to be enrolled and managed, and therefore it definitely depends on the use cases and implementations to be supported by this kind of key management. Therefore, I tend to maybe just extend the section 7.1 to give some more high-level general guidance on how to pick a set of algorithms, and then maybe just introduce these keywords for the algorithms, which we then refer to in the lightweight Cmp profile, and don't require a mandatory to implement set of algorithms there. Okay, so for these general guidelines on how to pick an appropriate set of algorithms from this document, I know there are some guidance already in 5480 on elliptic curve cryptography algorithms, and there is at NIST and Ecrypt there are sections. So maybe we can extend the section 7.1 if there is any guidance from the group or anyone who is more expert in crypto than I am. I'm happy to get support, and I think this is it then mainly for the Cmp algorithms draft, except there is feedback on the content from the group. Okay, so next slide, please. The Cmp updates document, there was also quite a larger number of changes to the document. On the one hand, due to David's detailed review, I did a number of changes on editorial level, but also with introducing a new version of Cmp. So the version 3 that is to be used whenever a transaction requires support for envelope data, which we introduce in this draft. And the client is capable of supporting that. It should indicate Cmp 2021 as a version. And this, of course, had effect to a number of other sections where this needs to be referenced. I hope this is specified clear enough. I also ask others on the mailing list for giving feedback, especially the colleague who raised this point from an implementer's perspective. Good. So there are also other topics that we updated. There is some discussion going on whether we need a extended key usage on Cmp CA for the Cmp CA. I think it's consensus that extended key usage for Cmp array is valuable. I will come to that on the next slide. I, of course, referenced Russ, new draft. Yeah, here we are with the extended key usage topic. So the question is the following. The role of a CMP CA is either indicated by using the CA key itself on the CMP endpoint, or by delegating this role to some other key. Sorry. To some other key and indicating the authority to speak as CA by this key, extended key usage. Now the question that came up is whether this could then also be called an array. If this is another entity with because it uses a different key. And the question was, what is the value add in having a specific extended key usage and being able to do this delegation to another key? So I know that this extended key usage was originally introduced in CMC updates, and that is where I also borrowed this specification from and the differentiation. But I do not really know what the exact motivation at that point in time was to also introduce a CMC CA role. Is there anybody who recalls what that use case was? And then maybe I can more easily figure out whether this use case would also apply to CMP. Okay, so no one recalling. Sorry, we can't ask Jim anymore. So yeah, I will have to see and figure out. Maybe I post the question again to the mailing list. Maybe there is some feedback.
Yeah, I fear that we won't find out, but we know also that the CMC RA bit is being used in EST.
Definitely, yeah, and also in Brisky to identify the registrar. So this for sure makes sense, but the other extended key usage I was not able to better explain. Yeah. Okay, next slide. Deb, please.
So in this case, are you using the entity that you've delegated? Is that entity actually signing the certificate, or is it acting like an RA?
The CMP CA would be the entity that signed the certificate, but maybe it has the CMP endpoint on a different machine, and therefore would like to issue or use a different key there.
And does that actually act like an RA, or does it do something different? Like, does it just approve the cert to be signed, and then the CA actually does the signing, or does that delegated thing actually sign the cert?
No, the delegated thing doesn't sign the cert, so the CA is uses the CA key to sign the cert only. So it just signs the CMP message, and therefore the question is it important to know that this message signing of the response was the CA, or would an RA be sufficient there?
Yeah, I don't know enough about how CMP works, unfortunately. I know we use RA, so operationally, not just in protocols, but operationally we use RAs all the time to approve a cert to be signed, and the RA says, yes, go ahead, sign the cert, but the CA actually does it.
Yeah, but that is more a question of the request side of the message exchange. Therefore, the RA is important there. On the response lab, when the certificate response message is returned containing the newly issued certificate, yeah, there is no real RA action needed.
No, well, no, and we don't use an RA for that. I mean, the cert gets returned however it gets returned, and the RA doesn't. I mean, we don't need the RA at that point.
Yeah, we just need it as a hop, and the entity that is in direct contact to the end entity, and therefore it forwards the return message, response message from the CA to the end entity. More or less, that's it.
No, I don't have any good answers for you, unfortunately.
Yeah, but thanks for supporting. Okay, so the two further remaining issues in Cmp updates are the two sections on the support messages for root CA update. So I think we discussed that in last IETF already, and in the past week we also had internally some discussion and tend to take the solution from last IETF on the certificate request template question to put the name into the header, into the general info header field. For the root CA, we do not yet have a good suggestion, either to put it into the request message, the old root certificate, or to as well put it into the general info field. Yeah, so both could be easily specified. So we will probably come up with a suggestion on the mailing list or in an updated draft. If there is any input right now, I'm happy to hear. Okay, next slide, please. The lightweight Cmp profile, probably there is more to do than in the two other documents still. So I did adapt the document to the changes of the two other documents. I introduced the algorithm names as specified in Cmp algorithm section 7.3. I did adapt to the new syntax from Cmp updates, also introduced the new version numbering, and I deleted the section on the discovery mechanism, and I updated, or David provided the update in Appendix A as an example for the certificate request template. Next slide, please. There was one open question also in last IETF with regard to which could be proper examples if we want to use a shared secret based HTTP authentication. And finally, Stefan had a closer look into it and provided this as a proposals for TLS 1.2 and TLS 1.3. So I would like to add this to the draft. If there is any feedback or other proposals, I'm happy to get your input. Okay, next slide, please. So the remaining to-dos, as said, we have a little bit more to do in Lightweight Cmp Profile, but anyhow, I think we'll now manage to get this done in the next month. We need to double check the preconditions paragraphs in section 4 or in the subject sections of section 4 to have this consistent and easy to understand. We are right now discussing whether to extend flowcharts or maybe also add a state machine diagram to the document, because we got the feedback from implementers that this would help a lot, and so maybe we come up with a proposal there. We are already simplifying the error handling or error reporting and updating section 4.3 and 5.3 to make this also more stringent and easier to implement. Hopefully that helps. We need to update the support message sections with regard to the things we discussed for Cmp updates, of course, and we are discussing whether in section 5, which addresses the PKI management operations among RA, LRA, and CA, whether to add whether to add requests responding on requests to the section. Currently, we only have different variants of forwarding sections and doing action of RA-like actions while forwarding. So we will also come up with a proposal there when this idea is settled. So I think this is it from my side for the update and the to-dos, the remaining to-dos on the documents. Is there any feedback, questions from the group? Okay, so then I would say thank you, and we can go on with the next topic.
Okay. DKG, did you want to talk about the mail guidance document?
I can do that. I don't have a set of slides for it specifically. My impression was that when the rechartering was done, the next step would be a call for adoption.
That is correct. I think we're going to do those in parallel. Send the charter with the assumption that it'll be approved, and then so that by the time the charter does get approved, the adoption will just happen as the next step.
Okay.
Does anyone have any objections to that? I mean, there's still some discussion going on about charter topics, not this one, right?
Yep.
Okay.
Yep.
All right,
I want to point out.
I just wanted everyone to know the plan. That's why I put it on the agenda.
I appreciate that. I will point out that I was looking at the draft the other day and realizing just how many to-dos and fix-me's there are there. There's a lot of nuance in making a good mail user agent that is capable of doing end-to-end crypto. And I am hoping that folks in this group who have some of that experience will contribute their the tricks and wrinkles that they found, because it is not at all clear that anybody has figured out all of the pieces of it and put it together in a single mail user agent that we can all learn from. So, I'm happy to work on it. I'm looking forward to working group adoption if we can get there. And I'm also really would be eager to hear more substantive suggestions from implementers.
All right, I'm not hearing anyone speak against that plan. And Deb's going to start making comments again on the document, right? Okay. All right.
Thanks, Deb.
All right, Renee, you're up.
Hello. Thanks for.
Renee, you want to run your own slides?
Sure. Well, you can do it as well if you want, but I don't know how I can move from one slide to the next.
All right, then we will
Just
have
say
Rowan
next.
do it.
Question again, please. Thanks.
All right. Question is whether you see something right now.
It says, oh, there it is. I can see it.
Okay. All right, this is the first time I use this service. So what I wanted to talk about is ways to speed up the signature verification with Ecdsa, and see how we could potentially use this in certificate verification and other verifications. So it has some technical details in it, but the main message I think is pretty simple. But I use some notation that is a little bit mass oriented. So apologies for that in advance. So this is the outline. So we have in IETF protocols, we usually use two types of signature schemes nowadays. One of them is Ecdsa, it's almost deployed universally. And another one is Ecdsa, which came out of the CFRG group. And I would briefly discuss some details of how they compare, and some pitfalls of of Ecdsa when you, for example, have to verify 100 signatures at a time. And the objective of this talk is to suggest a way to actually make batch verification, as it's called, happen, and see how we can morph this into the existing specifications. So this slide has one of the signature schemes is Ecdsa. You all know about this, has been used all over the place. And the next slide has actually Ecdsa on it. There are also some signature schemes that have been used with PKICs that are national ciphers. For example, Chinese SM2. There's German ECGDSA, Korean ECKCDSA. So I only use elliptic curve based things. So that's my presentation is only about that. And Russian ghost signature scheme. But for the purpose of this talk, I mainly talk about Ecdsa and Ecdsa, although on the last slide I will refer to extensions of how it may make it work with anything. So Ecdsa, the signature consists of two components. The important thing to remember is that the first component R is derived from an ephemeral signing key. And it's actually the x-coordinate of this point, modulo the order of the curve group. But essentially for most applications, we can think of it as the x-coordinate of the ephemeral signing key. So if you look at applications, then Ecdsa with the NIST prime curve P256 and SHA-256 is used almost anywhere. Now, since a few years, we also have a standardized alternative, which is based on SNOR signatures. It's the scheme called Eddsa. And most commonly used is ET25519, where the main selling point, I think, is increased speed. And it uses SHA-512 under the hood. There, the signature is actually, it's similar to Ecdsa. So Ecdsa had 2 integers R and S, and this one has what's called here a capital R and S. And with Ecdsa, the R component was the x-coordinate of the ephemeral signing key, and here is the entire signing key, except in compressed form. So I'll just contrast those two. So these are the 2 main schemes. The scheme Ecdsa has only been defined to work on so-called Weierstrass curves, which are all the NIST curves, the brain pool, and so on. And the wire format of the Ecdsa signature itself is the small rs, where R can be considered to be the x-coordinate of the ephemeral signing key. With Eddsa, we have, as I already said, we have the compressed ephemeral signing key as one of the signature components. And if you just look at the signing process itself and the verification, then we can look at some aspects that could be relevant. One is the number of message passes required to do the signing. In Ecdsa, it's once, and in Eddsa, it's twice. In Ecdsa, the ephemeral signing key can be generated offline, and in Eddsa, it's generated during the signing process because it depends on message. And then Ecdsa requires an inversion, which can actually be done offline, while Eddsa does not require an inversion. But what I really want to talk about is what happens on the verification side. So there you see that the Ecdsa does not allow easy speed-ups of signature verification, just a way of how verification works. And I will detail that later on. And it also does not allow batch verification. And if you look at Eddsa, it does allow both of those things. So the question is, would it be possible to actually, on the verification side, get speed ups for Ecdsa? And actually it is. So I'll first introduce a slightly modified Ecdsa scheme, which does this, and then I will talk about how to morph this into looking exactly the same as the current Ecdsa scheme. So on the next slide, I have this modified scheme. It's called Ecdsa with a little star. It is the same as Ecdsa, except instead of having as one of the signature components the x-coordinate of the ephemeral signing key, one uses the compressed ephemeral signing key, similar to Eddsa. And it turns out that that single change is enough to allow easier speed ups and batch verification, similar to what Eddsa was able to achieve. So the difference is really that we have access to the ephemeral signing key. So just to go over it in brief detail, if you look at the verification process of ECDSA, it's so well known. One has the signature components R and S. One has the hash value of the message. And what one does is one computes a combination of the base point and the public signing key to recompute the ephemeral signing key and then see if it maps to the first signature component R, small r. So with ECDSA star, the difference is that now we have access to the ephemeral signing key itself instead of only the X coordinate essentially. And if we do the verification process slightly differently, we can actually take advantage of some properties that allow these speedups to work. And once again, this works the same with ECDSA as well. So the process is depicted in the middle of this slide. From the first new signature component, capital R, so that's the compressed ephemeral signing key, we derive back the X coordinate essentially, and then we compute the full ephemeral signing key from the compressed one, so we use point decompression, and after that we check again a linear equation. And the key point there is that this is a linear equation in the so-called elliptic curve group. And the trick thing now to remember is that this equation can be rewritten as a combination of the ephemeral signing key, the base point, and the public signing key being 0, the identity point of the curve. And all the speedups that we can obtain with signature verification for discrete log systems, they're all based on manipulating this essentially homogeneous equation by randomizing it or adding a bunch of randoms together. And the thing to remember, I will not explain in detail how to get these speedups, but they're based on picking this lambda value that I put on the slide in an appropriate way, which can be done very efficiently, or they can be combined if one wants to do batch verification. And the result of that is that one can either do elliptic curve calculations with shorter so-called scalars, which translates to more speed right away, or one can group certain terms together so that one has less scalars to deal with, and we can amortize doubling operations. So in the single verification case, we can get roughly a 30% speed up. And if one has a bunch of ECDSA signatures with this little star notation, then one can actually get the speed up of factor 2 up to possibly even like 4 or 5. And this could be very useful if you have to verify lots of these things. So for example, if it's a certificate chain or you want to do something like that. So the important difference between those two schemes is that ECDSA and ECDSA star, they look exactly the same, except for the first step. Because in ECDSA, one only has the X coordinate of this point R, capital R, and in ECDSA star, one has it. And if one could go back from the X coordinate to the full point, these two schemes would work the same way from an efficiency perspective. And unfortunately, that's not the case, because you have a key, and the negative of a key, they map to the same small r value. So the question is, how do we solve this problem? So the problem is identified again on this slide. The problem is we have, if we want to, we had mapped the ephemeral key to the first signature component, small r. How can we uniquely go back without ambiguity? And in general, one has ambiguity because one has confusion whether this point was actually r or minus r. It turns out that for most curves, this ambiguity can easily be removed. So that's what I called the modified signing procedure. So what you essentially do is you generate an Ecdsa signature as you have done probably the last 20 years. And then if the y coordinate of this ephemeral signing key, capital R, is odd, you just change it to minus that point. And that corresponds to, in Ecdsa, toggling the S component of the signature to minus S. An important thing to remember there is that if Ecdsa signature RS is valid, then so is R, minus S. So some people call that malleability. But it can be used to essentially pick the signature in such a way that one can predict which of the points R and minus R actually is the right one. And more importantly, anybody can do that after signing. So you don't have to go, if, let's say a CA signed your Ecdsa signature, you don't have to go back to the CA to have it re-signed. Anybody can flip the sign of the S component of a signature.
Excuse me, Renee, could you help me out when you want me to flip the slide? Could you let me know so? Because I'm trying to kind of time it and guess it right, but I don't know what the next slide is, so I'm never sure whether it's the right one to flip now. Thanks.
Oh, okay. So you're actually flipping the slide? Okay.
Flipping the slide.
I'm on slide 9 now. I will
Yes.
indicate it moving forward.
Yes,
My
I'm on
apologies.
slide 9 too. Perfect, thanks.
Okay. So the essential thing to remember is that anybody can manipulate an Ecdsa signature by changing the sign of the S component. And it can be done by the signer, but it can be done actually by anybody because a verifier would not have any way of knowing that. And that fact can actually be used to make sure that we can essentially encode the compressed ephemeral signing key into the R component this way. So if you use this modified signing procedure that I outlined on this slide 9, then the verifier, usually it has confusion about which of the two R or capital R minus capital R would be the proper signing key. But in this case, it's not the case anymore because it knows that the y coordinate is even. So since a point and a negative of the point have different parity, it can uniquely go back on this mapping. So the bottom line is if you use this modified signing procedure, then some of the ambiguity in trying to recover the ephemeral signing key is gone. And as I said on slide, let me just go back here. Slide 8, that is essential to get all the speedups. For the speedups, you really need the ephemeral signing key. So now I go to slide 10. So how can we use this trick?
You have a question from Scott.
Oh, okay. All right. Yeah.
Hello, can you hear me?
Ask it now? Yeah.
Actually, it's not so much of a question, but I noticed about IPR. I've seen this base idea from Certicom, and I believe they may have patented it.
Yeah. So we can discuss more about that, but I think the essential IPR issues are gone for the signing side, and they
It's
will be mostly gone.
Okay. Okay, we can discuss this offline, or I just wanted to notify the working group that I believe there might be some IPR issues here. If you've already looked at them and decided that that they're okay, you're okay, and the group agrees, that's fine.
Yeah, so I prefer to have first a technical discussion, but the point compression has also been applied, for example, in Ecdsa, right?
Well, no, actually, their idea was to actually basically have the signature include the value capital R rather than low r, and then use Shamir's operation.
Yeah, I know what idea is, but it uses exactly the same point compression, and point compression patent has expired a few years ago.
Yeah, but they also use it to also accelerate Ecdsa, which has I do not believe that idea has expired.
Yeah, but I'm.
Oh, we're
I'm a little confused now because I'm in the middle of a presentation outlining things, and now we're going to torpedo it by IPR discussions. Like, I'm not even to the how to transition and who could use this slide.
Yeah, I'm sorry. Just that the note well says if I know about potential IPR issues, I should bring them up. I am bringing them up. Thank you very much.
All right. Okay, so where was I? Okay, I was on slide 10. I have 12 slides. So how to transition to Ecdsa star? Essentially, for all deployments of Ecdsa in real life, they use prime order curves. We just have to implement the modified signing procedure if you want to make this universal. So one option is, let's just look at the entire stock worldwide of Ecdsa signatures and just put them in the right format. So if we just we can recompute the signing key for any valid Ecdsa signing key has an odd y coordinate, just change S to -S. So once again, remember that anybody can do this, right? So you don't have to go back to CA or anything. So in particular, each user of an Ecdsa cert, for example, can do this calculation via an app or whatever, right? So it can swap it locally, or I just checked on Let's Encrypt. They have, let me just look it up here. They had a press release on February 10th where they said that they could issue already 200 million certificates in a day. So they should certainly be able to change, to make these verification friendly also in one day, right? So that would be a big bang operation. So this is probably a too optimistic model, but it would be, let's just look at who has produced Ecdsa signatures to this very moment. Let them each do this modified signing trick, which anybody can do, not just the signer. And from then on, let's just produce them all in this friendly way so that verification will be able to reap the 30% or more efficiency gain. So obviously this requires everybody to pay attention, and because otherwise a big bang has some delay impact, right? So option 2 would be to mandate in the specification. So for example, if you look at TLS 1.3, there somewhere in message flow there could be a certificate verification, but the participant in the TLS 1.3 protocol, they could just be required to put, if they use an Ecdsa signature, to put this S coordinate to change S to -S if appropriate, which is equivalent to using this modified signing procedure. So it can be done without even having to flag anything as long as you write it in a protocol specification. Same can happen with OpenPGP. I looked at lots of these things. Lots of these things are very easy to do once you write it into the spec. Then you soon, of course, people read the specs. Right? So that allows verifiers to use more speedy signature verification. It does not require them to use it. It facilitates speed-ups. In the signing side, the only thing that has to happen is essentially point compression, which has no IPR issues, as I said, anymore. So to Scott Fleur's point, this approach of modified signing process allows people to reap verification speed rewards. It does not mandate it. If people want to go slow, let them go slow, right? So now we have option 3 is Big Bang or mandated in specification. A different one would be, if you look at the RFC 5280 with certificate formats, maybe we can actually put some information in there that flags whether this modified signing procedure has been used. Because the crux is that verifiers should ideally know that this modified signing procedure is used, because then he can always get the 30%. Otherwise, he can still do his thing, but then the speed up may vary anywhere between -5% and 30%. Right? So there are two approaches there, and I just go to the next slide, slide 11. I copied the last option 3 on that slide, so don't worry. So one thing to do is to introduce a new object identifier for Ecdsa variants that use this modified signing step. So we have a modified OID in the PKIX search. And anybody who recognizes this modified OID, so let's say new devices, they can do the speedy signature verification. They can also do this, the original slow one, if they choose to do so. So Scott can be reassured. The only problem is that old devices, so devices out in the field, they may not recognize the new object identifier and may thereby drop that cert on the floor or not be able to process it. So all devices would have essentially need a parser to distinguish between the pseudonym OID for Ecdsa with a little star or the original one. So if they can swap that back, then they can still process as usual. So there may be a slight downside. So that's in the ref 1 of my draft. But since then, I've also looked at other ways of achieving the same goal, where all devices could still move ahead without any impact. And I'm not entirely sure whether this would work, but one thing could be to flag that this modified signing process was used as only basically conveying one single bit by putting a non-critical extension in a certificate where all devices who don't recognize that non-critical extension, they can simply ignore that one. And new devices, they will just use it. So the only thing, to my knowledge, if I look at correctly at the 5280 specification, is then we need to have an extension ID that could codify this helper information, which is essentially, did modified signing for Ecdsa get used, yes or no? So this could be attractive because then both old and new devices can just verify Ecdsa as they have implemented. And while exploring this a little bit further, I also looked at all the other signature schemes, so all those national schemes like Chinese, German, Russian, Korean signature schemes. They all use somewhere the X coordinate of the ephemeral signing key. By being able to essentially flag it in non-critical extension, all those signature schemes would also be able to use those speedups. So the bottom line is that it may be possible to not only speed up the Ecdsa verification, but also all these other discrete log-based signature verifications this way, both in batch and single setting. So now go to the last slide. So the summary is that contrary to popular belief, Ecdsa verification can actually also be sped up, not only the Eddsa, both in a single verify and the batch verify case. And in the most common case with the prime order curves, this only requires 1 bit or consensus in the protocol specification to use this modified signing procedure. It's possible to extend the approach to almost all discrete log-based schemes. And I've looked at some implementations of this. So the public ones that are not somewhere in a corporate network that has been used since 2012 in vehicular security arrangements. And I just looked up a report by the US Department of Transportation, and that uses this specification. It's unclear, of course, who has enabled this feature, but I believe that for the IPR conscious people at the time, there was a patent waiver provided to this IEEE audience. But I don't really want to talk about those issues because it's not my IPR anyway. I just think it's a neat technique that is underutilized. So that's his brown line. The techniques have been known since 2005. And I actually presented this already in July 2010 at what is it? 32 IETF sessions ago. But I think it's time that we start using some of these things. So the question is, do you think this has merit to be explored further? Should we try to see whether we can entice users in certificates? And what do people think about the transitioning option? So I talked about an object identifier or a non-critical extension. And I think that's the only topic is how do we encode it? And apart from that, I think this draft could be very quick because there's almost nothing else in there than specifying the modified signing procedure. So the main question is the bottom of the page. Is this useful to the group? And would this be suitable as a working group? I'm willing to do the work on it. I don't have any stake except loving cryptography and would like to see some of these things being used more widely. Any questions? So just to be clear, if this technique would be used, this modified signing procedure, to my knowledge, and I really look at some of the underlying work, there is absolutely no non-technical hurdle of switching this S component to -S and trying to run into patent issues because I don't think they exist.
Go ahead, Dimitri.
Hello, I have some questions. Could you please switch to the slide with the options you enumerated? Don't remember.
Excuse me?
Number. Here, yes, here. The first question: will will a suggestion work with the curves with prime order with cofactor not equal to 1?
I think it will work for. You probably refer to using the ghost scheme with.
Yes. Yes.
Okay, with the cofactor 4, right?
Yes.
So I think it will work in that case as well. It does not work that well for batch verification, but for single verifications, I think it will work.
Okay. Sorry. Okay. I'll ask my second question a bit later.
Okay. Any other questions?
Okay, could you please confirm the version that was said in chat during your presentation that Ecdsa star signatures are verifiable with the same mechanism as Ecdsa current?
Correct.
Huh? Sorry. So the new signatures are compatible with the old one from the verification point of view?
Correct.
Okay. Thank you.
Yeah, and I think that's crucial to make transitioning processes work more smoothly, right?
Yes.
Because people have an option to either ignore speed ups or not.
Okay, not seeing any more questions. I think Scott posted in the chat a pointer to a possible patent concern. Needs further investigation. And then I think we should continue that discussion on the list. And then once that discussion is sorted out, if it's favorable, we then do a call for adoption. Does that make sense to everyone?
So,
Okay,
so
Renee,
I don't know what this patent concern is, but once again, this trick is only on the signing side, right? But okay, let's investigate this.
Yes, but there's it's not just CAs who do signing, right?
So verifiers don't have to use speed ups. It just
but in the SMIME context, everybody with an email address would be generating a signature, right?
Yeah. So if there's a patent on the signing side, obviously that would be a problem. But if it's on the verification side, people can just choose not to implement it if they are concerned about this, right?
Correct.
So I actually did some due diligence, and of course I'm not a patent lawyer, but all of these issues, if there are any, and they are based on let's say Suricom past, they will go away within like 4 years. But we have to prepare for that future. So if we only start to act after things have changed, similar as we now prepare for post-quantum things, we don't only want to start thinking about things once the quantum computer is actually existing, right? So we have to anticipate some things.
Go ahead, Jonathan.
Hi. You mentioned that it's been deployed in the V2V, the P1609.2. Did they use certs? And if so, what option did they use?
They have Ecdsa signatures. So they have two types of certs. So one is an implicit certificate, and the other one is an Ecdsa certificate. With Ecdsa, they have two representation formats. One of them is using the Ecdsa as original, and the other one is using a compressed ephemeral signing key, as I also put in the slides. So that's essentially they allow both. And any device will be able to will generate them in that way. But obviously, on the verification side, it depends on the implementer. Most likely, somewhere in some people servicing the automotive industry, whether they implemented this, right?
My understanding is they use their own certificate format, not X509. Is that right?
Well, yeah. So they not X509, and I actually sent a note to William White because he is very active in this space. And, it's not entirely because I think it's their own format, but I think they have even submitted a draft to IETF spelling out this format, but I haven't looked it up yet.
Okay, at this point, we're out of time, so let's continue this discussion. And Mike, maybe you could start that thread with the question you just put in chat, because I think that's a good point to be asking. All right, thank you. And this will be the last session of the IETF. Safe travels home.
Thank you.
Be well.
Bye.